Number 3, use the table and graph from item 1. A. Use appropriate tools strategically. Using graphing calculator to determine a quadratic function h of t for the data. Okay, so the first thing we're going to do is we're going to go to Stat, and we're going to go to 1, which is Edit, and we're going to clear out our L1 and our L2 by going up to L1, pressing clear and enter, and it'll clear out that whole column. Because we need to input our table into the calculator. So in my L1 column, I'm going to put in 0 all the way to 6. So 0, 1, 2, 3, 4, 5, 6. In my L2 column, I'm going to put my heights. 512, 560, 576, 560, 512, 432, 320. Okay? And then what we're going to do is we are going to go to Stat again. Go to Second Quit. I need to get back to the home screen. Okay? Now press Stat. We're going to go over to where it says Calc at the top. And we go down to Quadratic Regression because this is quad, not a linear function. We stored our X in the L1 column. We stored our Y in L2. And I'm going to go down here to where it says Calculate. What it does is it gives me a formula. It says y equals ax squared plus bx plus c, and then it gives me values for a, b, and c. So I'm going to put that in, and remember it says call it h of t. So we're going to say h of t equals negative 16 x squared. I should say t squared because we're dealing with t's, plus 64t plus 512. Now, I want to look at the graph of this function. So what I'm actually going to do is I'm going to go to y equals. I'm going to turn my plot off. But in y1, I'm going to put in negative 16 x squared, because I have to use x's over here, plus 64x plus 512. And then what I'm going to do is I'm going to go to Window, and I'm going to change my window to match that of the graph here. So on my x-axis, I need to go from 0 to 10. So 0 is my min, 10 is my max, and it goes by a scale of 1. On my y, I need to go from 0 all the way up to 700. In this one, each line counts as 50. So my scale is going to be by 50. And then I'm going to graph this. And we see this nice little curvature here. Well, I want to see what that point is down there. So I'm going to go to Trace. And I'm going to type in the number 8. And notice that at 8, it was indeed 0. That way I could get a better graph. And I'm just going to go over here and I'm going to say C graph. Give a reasonable domain and range for h of t within the context of this problem. Be sure to include your units. Now, domain are all my x values. Well, in this case, time, my t values. What's the smallest t value we can have? 0 seconds, because that was when the engine burned out. What's the highest t value we can have? 8. So we're going to go from 0 to 8 seconds for our time. So we've got domain is 0 is less than or equal to t, which is less than or equal to 8, and these were in seconds. Let's talk about our y values, or the height. What's the lowest height we could have? 0. 0 feet. Because guess what happens at 0 feet? The rocket hit the ground. Okay? And what was the highest height? 576. So our range is 0 is less than or equal to h of t, which is less than or equal to 576 feet. Use the function found in item 3 to verify the height of the spirit when the engine burned out. So remember that when the engine burned out, it was 0. Time was 0. So what I'm going to do is I'm going to use this function, and I want to find out when time is 0, what the value is. So we would have negative 16 times 0 squared plus 64 times 0 plus 512. 0 squared is 0. Negative 16 times 0 is 0. 64 times 0 is 0. Plus 512. Well, 0 plus 0 plus 512 equals 512 feet at the start when the engine burns out. Go ahead and take a moment to get this copied down. On the next slide, we will move straight into question number 5. There is no debriefing for this section.